Okay, so in this example 8, it says find the missing coordinates. So we need to find the coordinates of S and T. And then it says, then show that the statement is true. They want you to show that this is true. So that's saying, prove it. Oh, don't know how to spell prove. There we go. Prove it. And I know you love hearing that word, prove. So there it is there. So that's what they want you to do. Now, whenever you're doing coordinate proofs, there's 3 formulas you're usually going to use, not necessarily every time, but these are the 3 to check. If you forget one and you start getting stuck on one of these coordinate proofs, it's usually because you forgot it. And so let's remember what the 3 formulas we've learned this year to use with coordinates. Okay? The first one is the midpoint formula. Okay? The midpoint of any segment is the average of the x's. So x1 plus x2 divided by 2. The average of the y's, y1 plus y2 divided by 2. Okay? So we get that there. The other one is for measuring lengths. It's the distance formula. And I'm going to write it again because I know even though we should have it memorized, some of us don't. Just find the length in the x direction, square it. It's a Pythagorean theorem, remember. Find the length in the y direction and square it. And the final formula that we can use is to do with slopes. The slope of a line is the rise, which is the length of the direction going up or down, over the run, length of direction going left or right. So you got to use one of those 3 formulas, or all 3, or some of those 3, 1 or 2 of those, to do a lot of these problems with coordinate proofs. If you forget those formulas, it's trouble. Now, it turns out in this one, in this particular problem, these marks here mean each side is congruent. So that means this is a midpoint. And so do these marks mean the other side is congruent. So that is a midpoint. So we're going to use the midpoint formula, the top one there, which means I don't need the other ones yet, so I'm going to get rid of them for the sake of space. Well, I guess I could move it to the other page, but for the sake of space, I'm just going to get rid of them for now. So let me erase those things. Okay, so I erased those out of there, and you've got midpoint S. So S is the average of, well, I guess I should be careful here. And I'm going to call this x1, y1 down here at point P on the origin, and call this x2, y2 there. Okay? So when I do that, and the reason it's a proof is we don't have a lot of numbers in here. Now we chose 0 zeros because those are easy, but we don't know some of those other things. So we're going to use that as it is, and we get S is the average of the x's and the average of the y's. So what are the x's? Well, we have 0, that's convenient, and h. And the average of the y's is 0 and k. How convenient. So we get S is half of h and y is half of k. There's our midpoint. So we found one of them, so we're happy. We've done maybe a quarter of the problem. The other one that we have to find is t. We're going to use the same process. T is the average of the x's and the average of the y's. And so we get, now again, on this one here, we've got to be careful because I'm going to call this now x1 and this y1 here. So when I put them in, I'm going to get x's is 2h plus h, and y's are going to be 0 plus k. And so we end up getting t is 3 h's divided by 2, or 1.5 h's, and k divided by 2, or half k. And that is our other coordinate. And that's going to be really important for us when we do the next part of it, which is to show, and I'll do that on the on the next video, show that SR is congruent to PT.